Good morning, everyone. Thank you for being here with us. We're going to present for you today the PyCon project. So it's basically a SCSI packet injection. We're going to explain for you what does this strange name means. So this is our team. My name is Israel Costa. This is Ale Silva, Lucas, William, and Mateus. So have you ever read the book 1984 from George Orwell? Just to give you the scenario, in the book, people live in a society where the government controls everything, especially all the information. So let's think about today's world, where all the files are produced in a digital format and transferred via network infrastructures. What will happen if a malicious user was able to intercept a certain network and be able to sniff, to see everything that is being transmitted from a server to another computer? And this malicious user was able to modify the packets, the content of the file that's being transmitted, and transfer it to the final destination and be completely unseen. Well, we don't work for the government, but we're kind of the hackers today, so we're going to perform an SCSI packet injection. So what makes our project really, really special is because we are doing this attack in a SCSI environment.
Well, this is the outline for our presentation for today. We are first start to talk about the background behind iSCSI. Then we are going to show you some simulation results of our project, and also the challenge that we faced through our path. Before talking about iSCSI, we have to talk a little about the SCSI. That stands for Small Computer System Interface, and it's a set of parallel interface standards for physically transmitting data between computer and device, such as hard drives and CD drives. The iSCSI is a SCSI protocol mapped to the TCP/IP and sent through the Ethernet connection, using a target machine with a storage device working as a server and the initiator working as a client trying to access this data. This image shows you guys how the SCSI package works. The SCSI data is encapsulated with the SCSI package, and using the TCP/IP protocol is sent through the network to the target machine.
Well, more like about our project setup. In our project setup, we have 3 virtual machines. We have an initiator machine, a target machine, and a main-in-the-middle machine. In the initiator and the target, we have they are configured using Vagrant, a tool we used. And for the target machine, we configured using mounting commands to mount the data and to serve the data to the initiator. In the initiator, we configured with commands to log in and to discover the iSCSI target file. Our target machine was configured using Ubuntu 16.04 Xenial and installed the package iSCSI target, which is a utility to serve our target LAN. And we configured a disk partition in the target to serve as our logic unit number. We can have one or more logic unit numbers, but you're using only one. And in this image, you can see the communication between the target and initiator, where the package goes to the iSCSI and SCSI layers to the TCP/IP, IPsec, and goes through the Ethernet to the initiator, or the other way around if the initiator starts the communication.
So our second machine is the initiator. It's also a virtual machine with Ubuntu 16.04, and we use a package called OpenISCSI. This package allows us to discover and log into the targets that are in the network, and also to mount the SCSI disk. That is a drive that we can access the files that were originally in the target server. The image we can see is the representation of each connection in a target with an initiator. Each target can connect to several initiators, and each one is a bridge, independent bridge. So each initiator cannot access or modify the other initiator's files.
And the last but not least, our system is the man in the middle, which runs on Kali Linux. It's an OS created with the focus of penetration testing and offensive security. And we chose that one because it has very wide variety of tools to discover and to defend the system. So one of the tools we use is Scapy, which is a Python package and library to RPoison, not just for that, but to do network programming. And to monitor the network environment, we use Wireshark, which is used for sniffing the packets. So what are the objectives of the man in the middle? He has to modify the packet and do it before the timeout window and to disappear unseen without being caught.
So we talked a lot, but let's make an animation to make things more easy to understand. So, just a second. Sorry. Oops. There we go. So we have these two main machines. The first one is the storage. The second one is the initiator. So the initiator will send SCSI commands to the target. So once it's logged in the target, it keeps sending SCSI commands and requesting documents. And these protocols are encapsulated into the TCP protocol. And then eventually the third machine enters in action. And this is when it reroutes the connection and he starts listening to the packets. And that's when we do the attack. When you get the file, we change the content of the file and we send to the final destination with the modified content.
So the results of our project was to build a functional iSCSI environment to read and identify the specific iSCSI packet that we wish to modify data inside the iSCSI packet and inject the modified data without letting the initiator, which is the client on a normal server client architecture, and leave unseen.
So in this screen capture, we can see the Wireshark. That is a tool that William said about. That we can see the flow of packets in the network. As you can see, the packets are all coded in hexadecimal numbers or digits, and to see what is inside the package, we need to decode this. So these red lines are the content of the file we are trying to modify. So this one is the original file that the target sent to the initiator, but was caught in the main middle. And this package was the this package was the package that man in the middle sent to the initiator. So it modifies the content and then sends to the initiator, and both initiator and target don't know that this packet was modified.
So we started with that test file that we shown earlier, but now we are able even to modify name of lists, such as FBI wanted list. We can change names when replaced with other names. So, and our challenges we faced was to automate the setup of the virtual machines using Vagrant. Vagrant, it's an automation tool that we use to deploy the virtual machines using scripts and to make able to set up the virtual machine with only running one command. So anyone at any time just needed to run one command and we would have the virtual machine running on time. The other challenge was to resend a modified packet on time and in order so that it wouldn't either time out or the initiator don't receive it. And the last one that we took a while to discover is that we need to change the packet size limit. That
That being said, the MTU, which stands for Maximum Transmission Unit, so that the packet goes through the network and does not get blocked because of the size of the packet.
All right, thank you everyone for being with us. If you want to know more about how to be a good hacker, feel free to ask us after this presentation. Thank you.